Hi all, welcome to Learn Code Repeat. Today we'll be looking at maximum subarray problem. It is also called as the Kadanes algorithm, and this is one of the most frequently asked questions in interviews. And this is also asked on Leetcode problem number 53. So let's look into the problem. So the problem says that you're given an integer array and you need to find out the maximum subarray, which means that within the integer array find a subarray which is having the maximum sum when you add all the digits of the subset. Okay, so if I have 2 minus 1 3 minus 9 5, right, so I will try to add 2 with minus 1 and check whether that value is greater than the maximum value I have till that point. Then again I'll add 2 minus 1 and 3 and check whether the sum of those values is greater than the maximum value that I have recorded till now, right? So one of the brute force approach is that I'll first consider this digit, that is 2, and then I'll check 2 with 2 and minus 1, and then again 2 and 3, and so this is the range, right? 2 and 2 minus 1, so 2 plus minus 1, then 2 plus minus 1 plus 3, then I'll include 9 as well here in this, and then at the end I'll include 5, right? So at each point I'll check what is the maximum that I'm getting by including each number, right? Once I complete it for 2, then I'll do the same thing for 1. So, or here in this case minus 1, right? So this is the first index. So minus 1 I'll do the same thing. And since it's a contiguous array, so it should be only going forward from here, right? So minus 1 and forward from here, right? So it will be minus 1, then again minus 1 and 3, then minus 1 and 3 and minus 9, and then minus 1 and 3 minus 9 and 5. Okay, so that way I can do it and check what is the maximum value, and at the end whatever is the max val I got, I'll return that. So every time I'll keep on updating, right? So for doing this way, a brute force manner, I need two for loops, right? One for loop for the initial ith value and the second for loop where the j is incrementing, right? So here in this case the start point is this, and then this j value is incrementing. So if we do this approach, it will be of O of n square time complexity, right? Is there a way that we can improve this, right? So one way to do this is using Kadane's algorithm, and the time complexity of that is O of n, right? So that means we are only going one pass through this whole array, and through that we can find out what is the max subarray or maximum subarray. Okay, so let's check what the algorithm is. So what this algorithm says is that at any given point you need to find out what is the maximum till that point. So if I'm going over the array at index 0, I'll try to find out what is the maximum at that point including that element, right? So since at index 0 this is the first element, the maximum is 2, right? Then I'll go to the next element which is index 1, right? Here including this element and adding this element to the previous max, right, what I had, I'll try to find out what is the maximum number. So this element is minus 1, and if I add this element to the previous max, right, previous max was 2 in this case, right? So 2 minus 1 is 1. So if I compare both the values, one is 1 and second is minus 1, the answer here will be 1, right? So till this point I'm having 1, right? And then I'll again go to this point. I'll check including this element and adding this element to my previous maximum, what is the max value. So only this element is 3. So if I only include this element, it will be 3 as the max value. If I add this element to my previous max, right, my previous max was 1, so if I add 3 to 1, it will be 4, right? So I'll get my max value till this point will be 4, right? And so on, I'll go to the next one, right? So you got the pattern, right? So let's check the pseudocode for this. So here we are declaring two variables. One is the max val and one is the current max sum. Current max sum is the current sum that we are checking at each point. So here we were checking either the current element or adding the current element to the previous maximum, right? That's what we are doing here. We are checking the max of the current element or adding the current element to the previous maximum. Okay, so current maximum is my current running sum. I'm adding that current value to the current running sum and checking whether the current number is greater or the current number plus my previous max is greater. Okay, so that is the value that is stored in current max sub. Then I'll check whether the maximum till now, that is the max, or this current max sub that I got, whether that is the max. It's similar to saying that if my current max sub is greater than my maxwell, then assign maxwell as current max. So I'll go over this in a loop, and at the end of the array, the maxwell value will store the maximum sum that I can get, because at each iteration I am checking and comparing my current value, which is the current element in the array. So I'm checking that value, and I'm checking the value where I'm adding the current value to the previous max sub, and whatever is the result I'm adding it to the maxwell, and then again comparing with the maximum between the two. Okay, so let's do a dry run of this. So here, right, in this case first I is 0, so first I am assigning the first element in the array to my maxwell and my current max sub, right, current maximum sub array. So initially it will be 2. In this case the first element is 2, so both the values will be 2. Okay, now I is 1, so my current max sub will be whatever is my current element, which is -1, or it will be -1 plus my current max sub. So my current max sub earlier was 2, so it will be 2 plus -1. So my current max sub becomes 1, and in the maxwell I will compare and check which one is the maximum between maxwell and the current max sub. So maxwell earlier was 2 and current max sub is now 1. So between 2 and 1 the max is 2. So this is my current value for current max sub and max. Then I'll go to second iteration where I is 2, right? So here the value of I equal to 2 is 3, right? So again, for current max sub, nums of I will be 3. It will check for maximum between 3 and 3 plus current max sub, whatever was my previous current max sub. Previously it was 1, so 3 plus 1 is 4. So my current max sub now becomes 4. I'll again compare it with my maxwell. My maxwell was earlier 2, and I'll compare it with my current max sub. It is 4. So my maxwell will now become 4 because 4 is greater than 2, right? Then it will go with I equal to 3. When I is equal to 3, the nums of I is -9. So I will check for max between -9 and -9 plus current max sub. Current max sub earlier was 4. So -9 plus 4 is -5. So the maximum between -9 and -5 is -5. So current max sub will become now -5. And maxwell I'll again check between -5 and 4, which one is greater. 4 is greater, so maxwell will remain as 4. Then when I is equal to 4, the value is 5. So nums of I is 5, and nums of I plus current max sub is 5 plus -5, which is 0. So between 5 and 0 the maximum is 5. So my current max sub becomes 5, and in maxwell I'm checking maxwell and 5 and the current max sub, right? So between 4 and 5 my max value is 5, so my maxwell is assigned with the value of 5. So at the end I'll return the value 5 here, right? So how it will be 5? Because if I only consider this element, the last element 5, that is greater than adding any of the sub arrays, right? So instead of adding any sub array and returning that sum, only this particular element I can return. That will be the largest element I can have in the subarray. Okay, because a subarray can have one or more elements, right? So I'll only return this. So this is the way of finding the max subarray using Kadane's algorithm. The complexity is O of n. There is multiple variations of Kadane's algorithm where instead of maxsum you can be asked for max product, or there is one more variation of maxsum where the array is a cyclic array. So that means that instead of from 0 to n, we have to also consider that this can go in cycle, and we have to find the maximum for that. Again, in that case you can still use Kadane's algorithm. That's it for this video. Hope you like this video. Please like, subscribe, and if you have any questions, please comment in the video. Thank you.